Okay, last time we talked about parallelograms, right? Opposite sides were parallel, right? They were parallel. And then they were also congruent. Like this was congruent to this one's congruent to this one. Opposite angles are congruent, like this one is congruent to this one is congruent to this one, right? So opposite angles are congruent. Consecutive angles, ones that are next to each other, like if this was 100, this would be 80. They're supplementary, right? So if they're next to each other, the corners are supplementary. Like that's 100, that's 80, that's 80, that's 100, 100, that's 80, right? Okay, each diagonal, let's make one diagonal. These two triangles are congruent, which we don't talk about much about that, but it's true. And then diagonals do some heinous act. They bisect each other. How gross. They cut each other in half, okay? So you got these two diagonals, and this one is congruent to this one, and this one is congruent to this one, but they're not all four the same size. You could have a 5, 5s, 7, and 7, okay? So that's what we talked about last time, parallelograms. Did you know that a rectangle, a rhombus, and a square are all parallelograms? You know why? Because they have every single parallelogram property. If I had a rectangle, just to quickly show you, doesn't it have opposite sides that are parallel? Sure. Does it have opposite sides that are congruent? Sure. Okay. Does it have opposite angles that are congruent? Well, of course, they're all 90, right? Okay. And then consecutive angles are 180. Well, 180, 180. I mean, or 90 and 90 make 180. That's 180. That's 180. That's 180, right? Okay, and then if I made a diagonal, it would make two congruent triangles, and then the diagonals would bisect each other. They would chop each other in half. But in this case, they would all four be the same, because the diagonals are the same length in a rectangle. Okay, so all of these guys are parallelograms, except for a rectangle has a couple of more qualities, okay? A rectangle has all parallelogram properties, just like we've been talking about, but it has these two qualities that are unique to make it a rectangle, okay? A rectangle has diagonals that are congruent, okay? Diagonals that are congruent. So RL is congruent to AE, okay? Rectangles also, and y'all know this, it has four angles that are congruent. You know, they're 90s, right, in the corners? So it has four right angles. Okay, four right angles, okay? A parallelogram is bent over like this, right? Okay, it doesn't have 90s. So these two qualities make it a rectangle. Rhombus. A rhombus is a parallelogram, for sure, because it has all six of those qualities, just like we've been talking about, but it has these three extra qualities that make it unique to be a rhombus, okay? So diagonals of a rhombus are, if you notice, they're perpendicular, which is kind of neat, okay? No matter how you squeeze it or turn it or whatever, it's perpendicular. So all of these are 90, okay? So the diagonals of a rhombus are perpendicular, okay? You remember the upside down T means perpendicular, so I'll say TL and AE are perpendicular, okay? So that's one of the qualities that makes it a rhombus. Okay, each diagonal of a rhombus bisects the pair of opposite angles. So it goes into this corner and bisects it. Oh, this thing's messed up. Okay. Let me put 2 here and 2 here. There we go. Okay. So if it's a diagonal, it bisects the angle that it goes to. So these two angles are the same. Okay. These two angles are also the same. So all four of these angles are the same. Now this diagonal bisects the two sets of opposite angles as well. So this angle and this angle are the same, and this one are the same. Okay? But that won't make sense to you until I draw it out like this. Okay? Let me draw this. Now we know the insides are 90s, right? They're all perpendicular. But this diagonal shoots up there and chops it in half. So it could be a 60, and then here a 60 and a 60, right? Okay? So this diagonal chops these two in half, so that's a 30 and a 30 and a 30 and a 30. Notice how you got a 90, a 60, and a 30. So these two always add up to 90. I could have a 50 and a 40. I could have 50, 50, 50, 50, and 40, 40, 40, 40, right? But just know that it chops each angle in half, right? That's that one. Okay, and then the one that's always recognizable is that the rhombus has 4 congruent sides. Okay, it's like a square, except for it's kind of bent over a little bit. All right, so these four sides are congruent. All right, so rectangle, rhombus, square are all parallelograms. Okay, now the square, super square. You know why? Because a square has every single parallelogram property, it has every rectangle property, and it has every rhombus property. So a square has every one of these 11 properties, okay? I mean, doesn't it have congruent diagonals? Well, sure it does, okay? If it's a square, then it's got congruent diagonals, it's got 4 right angles, right? You know, it's got diagonals that are perpendicular. These are all 90, right? Each diagonal bisects a pair of angles. These are all 45, 45, 45, 45, 45, 45, 45, and 45. So this one bisects that 90 and makes it 45 and 45. Same here, same here, same here. So all of those are the same. And then, does it have all 4 congruent sides? Well, of course, that's the signature of a square, is that the 4 sides are congruent. All right, so here we go. Here's where we have to think and use logic to figure out whether it's a square, rhombus, parallelogram, rectangle. So let's start plotting, okay? -3 and up 2 is A. Okay, B is 1 up 4. C is over 5 and up 2. And then D is over 1 and 0. Okay, so I'm going to do the best I can to try to draw the lines as good as I can so it looks like what it really is. Okay, so I always start out with parallelogram. Okay, I want to see if it's a parallelogram by checking slopes. Okay, so I check slopes first. But I look at this thing and I say, is this a square? I mean, is that a right angle? No way. Is it a rectangle? No way. So it's probably going to be a parallelogram or a rhombus, right? So let's find out. Okay, so the slopes, let's start off with getting the slopes of the ones that are positive, okay, the uphill ones. So the orange line slopes, see if they're both the same or not, okay. AB, the slope is, remember, you start from the left point and you go up and over, right? So that's up 2 and over 4. So the slope is 2/4, and if you reduce that, you get 1/2. So the slope of AB is 1/2. Now, DC should be the same slope if it's a parallelogram. Okay, so it's okay to go inside the shape, okay? It even makes it look like a 3D shape. It's kind of cool. Okay, so that's 2 and a 4. So DC is 2/4 for the slope, or 1/2. Okay, so what's true about the orange lines? Well, they have the same slope, so they must be parallel. Okay, so those are parallel. Okay, so now let's check the soon-to-be green lines. Okay, that's a green line, that's a green line, segment 2. Okay, so these are downhill, so you know they're going to be negative slopes, right? So AD and BC are going to be negative slopes. So that's down 2, so that's -2. And then 4 to the right, which is +4. So -2 over 4 reduces to -1/2. Okay? This one, down 2, you start from the left point and go up or down, right? So you go down since it's negative, so you go down 2 and then 4 to the right. So that's -2 over 4. -2 over 4 is equal to -1/2. So are these parallel? Yeah, they're parallel as well. So both sets of opposite sides are parallel, so it's at least a parallelogram. Okay, it's at least a parallelogram. So we need to check if it's a rhombus. How would we do that? We need to see if all 4 sides are congruent. Okay, if they're all congruent, then we know it's a rhombus, okay? Because it's got the parallelogram properties, and then we can prove that it's a rhombus, okay? So let's look for sides. Okay, we need lengths, distance, okay? So I kind of like to do this. I've already got right triangles everywhere, but whenever you're doing distance, don't you have to have a right triangle somewhere? So I'm going to use, I don't know, I should have used a different color, but I used green. Okay, so look at all those green right triangles. See the green right triangles? Okay, so for each green right triangle, then there's a hypotenuse, right, that we can find the distance of to see what, how long it is. Okay, so for A, B, B, C, D, C, and AD, they're all the same length because aren't they all 2, 4 right triangles? This is a 2 and a 4, this is a 2 and a 4, this is a -2. Well, it's a distance, okay? It went 2, okay? If it's slope we're talking about, we're going down 2. But if you're just talking about how long is that part, well, it's just 2. Okay, so that's a 2, 4, and this is a 2, 4. We're not doing slope now, okay? So we go 2 squared plus 4 squared. Remember the adding Pythagorean theorem? And I don't even know what that is. It's something like square root of 20, which is like 4 point, maybe 5? I'm just guessing, okay? But it doesn't matter. All of them have the same distance, right? So if they all have the same distance, then aren't all of these sides congruent? And if it's a parallelogram and all the sides are congruent, guess what? It's a rhombus. So that's my answer. It's a rhombus, and I'm sticking to it. All right, next. So -5 up 1 is A. B is 0 up 5. Okay. C is 5, 3. And D is 0, -1. Okay, so I'll make the lines. I wonder what this one is. What does this look like? Does it look like all the lines are the same length? Yeah, these look short and these look longer. Okay, so that helps to know. Okay, so it's probably not a square or a rhombus because those would be all the same length. And I can prove that here in a minute. But right now I'm just going to do the slopes, okay, to see if it's a parallelogram. Okay, so let's do the slopes. Okay, so A, B, and CD hopefully are the same. And then BC and AD should be the same. It should be the same slope so that the opposite sides are parallel. Let's see. Okay, so this is for the green lines. Okay, for the green lines, those are positive. So this is up 4 and 5 to the right. So that's 4/5 for a slope. Okay. Now this one DC, same thing, up 4 and 5 to the right. So that's up 4 and over 5. So that would be 4/5. So these are parallel. Yay. That's what I wanted. Okay, so heading towards being at least a parallelogram. Okay, so BC and AD. I'm going to do AD first since it's down here. Down 2. So now that we're doing slope, this is negative. So we say -2 and then 5 to the right. So the slope is -2/5. Okay, this one is down 2 and 5 to the right. So that's -2/5. So these are parallel because the slopes are the same, right? All right, so it's a parallelogram at least, okay? Because the pink sides have the same slope, so they're parallel, and the green sides have the same slope, so they're parallel, okay? So it's a parallelogram. Now we need to see if, we can tell that's not a 90, so I'm not going to check for a 90, and I'm going to show you later whenever it's time for a 90. Okay, so are all the sides the same length? Well, remember how I did it before where I'm going to use orange this time. And just, the reason I'm doing this is I'm making right triangles, okay? So this green line needs a right triangle. It's a 4-5. Okay, this one's a 4-5. But this one is a 2-5. And this one is a 2-5. So are all the sides the same length? Okay, so one of them, like this one right here, this green line here, is 4 squared plus 5 squared to find the length, right? Okay, this one over here, this BC, is the square root of 2 squared plus 5 squared. So obviously this one will be smaller than this one, right? So all the sides are not the same. Now the opposite sides are congruent, right? And that still fits the idea of it being a parallelogram. But it's not a rhombus because the sides are not all the same. So this is a parallelogram. Okay, let's look at this one. This is a rhombus. So AB is equal to 2x plus 17. BC is 3x plus 6. ADC, this corner right here, ADC, because that's going this way. ADC, the corner, is 82 degrees. Okay, so now it wants x. Are these equal? Can I set them equal? Yeah, of course, because a rhombus has all sides congruent, right? So I can set these equal. So 2x plus 17, because I want to solve for x, right? Okay, 2x plus 17 is everything. Am I on the page? Ooh. Y'all couldn't see that at all, could I? Oh, I don't want to start over. Anyway, basically I labeled it. This, okay, 82 for this corner, right? All the sides are congruent, so I can set them equal. I'm going to keep going. I don't want to start over. Okay, so I subtract 2x from both sides, and I get 17 is equal to x plus 6. So I subtract 6, and I get x is equal to 11. Okay, so that's 11. Now AD is the same as this one. So if I plug 11 in there, 3 times 11 plus 6 is 39. Now BDC. BDC is actually this little angle on this side, right? This little bitty angle. So how do we find the little angle if the big angle is 82? Well, in rhombuses, or rhombi, the diagonal cuts that angle in half, so 82 divided by 2 is going to be 41. Okay, this one's actually 41 as well. Okay, so that's 41 degrees. And then BCD, which is this corner over here, right? That corner would be supplementary to this one, right? It's not 82 as well, it's 82 and then 180 minus 82, right? Because aren't consecutive angles supplementary, right? So 180 minus 82 would give you 98. So this one's 98 degrees. What would this one be? Yeah, these are the same. This corner over here would be 82. This corner over here would be 98, right? And if you wanted the little ones, you'd just divide by 2 for each of them. For a rhombus, it's kind of nice, right? You just divide by 2 to find the angle. All right, so BCD was 98. And then DMA up the middle, DMA was this angle right here. And these are perpendicular, so it's 90, right? So that's 90. All right, so all of them are 90 in the middle, right? Because these are perpendicular lines in a rhombus. Okay, next. Okay, so A is -2 up 1. B is 1, -2. C is -2, -5, way down here. D is -5, -2. Ooh, it's looking kind of like a square, don't you think? We haven't done a square yet, so it might be a square. Okay, so we show that it's a parallelogram first, so we get the slopes. So DA and CB, then DC and AB. Okay, so if we can find those slopes and see if the opposite sides are parallel, then we'd know it's a parallelogram at least. Okay, DA is simple. It's, oh, the lights went out. Okay, but y'all can see, right? So this is up 3 and over 3. So that's 3 over 3, which is 1. Okay, this one down here is up 3 and over 3, right? So 3 over 3 is 1. Okay, DC is this one that's going downhill. So this is down 3, so that's -3 down, and then 3 to the right. So that's -3 over 3, which is -1. Okay, and then this one right here, AB, is down 3 and 1 and 3 to the right. So -3 and 3 would give you another one that's -1. Okay, so these are parallel and these are parallel because the slopes are the same, right? So it's at least a parallelogram. So far, it's at least that. Okay, we know that. So are all the sides congruent? Okay, are all the sides congruent? So let's do this thing that I do. Make a bunch of right triangles. Are they all the same right triangle? Is that a 3-3, a 3-3, a 3-3, and a 3-3? Yes. So all the lengths of these sides are congruent because they all have this, 3 squared plus 3 squared, and the distance would be whatever that is, 4 something. Okay? So this one and this one, this one and this one are the same. So they're all the same length. So it's either a rhombus or a square. Now here's the hard part we haven't talked about yet. How do we prove that that's a 90? If I can prove that's a 90, then we know it's a square. Okay? Hands down. It's not a rectangle because all the sides are congruent, but if I can prove that's a 90. All right. This has to do with, a long time ago, if we wanted to prove that two lines were perpendicular, if they were perpendicular, didn't they have opposite reciprocals? Remember, if you had a slope of, can you see? Yeah, 2/3, then if it had an opposite reciprocal, you flip it over and then change the sign. If it had this, then it was perpendicular, right? So if these were perpendicular, wouldn't that be a 90 right there? So that's what we're looking for. We're looking to see if the slopes are perpendicular, okay, or opposite reciprocals. So DA is 1, and then this one down here, DC, is -1. Are they opposite reciprocals? It's kind of confusing. But if I put 1/1, and I put a 1 under that one, okay, 1/1, if I flip that over, it's still 1/1, and then I change the sign, isn't it -1/1? Yes. So that's a 90 because these two lines are perpendicular. The orange line and the pink line are perpendicular because their slopes are opposite reciprocals, 1/1 and -1/1. Okay? Does that make sense? So this is actually a square. It's not a rhombus, or, I mean, that's not the most specific answer anyway. So it is a square. All right? Next. You put caps on this stuff. Hang on. Okay, here I go. Okay, so this is over 1 up 5 is A. B is over 5 and up 1. C is 2, -2. And then D is -2 up 2. Okay? So I'm going to draw this in. Is this a square? A rectangle? Parallelogram? I don't know. It looks like a rectangle because this side's short and this one's longer. Like it cuts off 3, 3 and this one cuts off 4, 4, right? So you know they're not the same length. So parallelogram. We got to do the slopes to figure out if it's a parallelogram first, okay, to see if the opposite sides are parallel. So let me put pink ones here, green ones over here, and see if those colors are parallel. Okay, so DA and CB should be the same slope. Okay, and then DC and AB should be the same slope. So DA is up 3 and over 3, which is 1. Okay, and then CB, this one down here, is the same thing. It's up 3 and over 3. So the slope is 3 over 3, right? So that's 1, okay, for the slope. Okay, DC is a downhill, so that's down 4. So that's a -4 down, and then 4 to the right. So -4 over 4 is equal to, I'm just checking to see if my phone was still working. Okay, so that's a -1. And then AB is down 4. Make sure I go to the right place. That's -4, and then 4 to the right. Okay, so it's -4 over 4, which is -1. So, because these are parallel and these are parallel, it's a parallelogram. It's at least a parallelogram, okay? I'll just put para. It's a parallelogram. Is it a rectangle? Is this a 90? Are these perpendicular to each other to form a 90? Okay, AD is 1, okay? DC, this one, the green line, is -1. We already discussed that over here, that these are opposite reciprocals. So that's a 90. So this is a rectangle. Yay. It was a parallelogram, and then we proved that it had a 90, so it's a rectangle. It wasn't a rhombus because all the sides were not the same length. And the reason that that's true is because that's a 3, 3, right? 3 squared plus 3 squared for the length of this one. And then this one would be a 4 squared plus 4 squared, so it's a different length, right? This is shorter, this is longer. So the sides are not all the same, so it's not a rhombus, so it ends up being a rectangle. Yay, okay? Last one of these types. A is -1 up 3, okay? That's A. B is 3, and then don't go anywhere, 0. C is 0, don't go anywhere that first time, and then go down 3. So that's C. And then D is -4, 0, okay? So it kind of looks like a rectangle, but I don't know. I don't really know. All right, so we're going to do slopes to see if it's a parallelogram to start with, okay? So let me put a D over here. So this is DA and CB. So those are the pink ones, right? And then this one and this one are the green ones. So that's DC and AB. So we're checking slope to see if opposite sides are parallel or have the same slope, right? So this is up 3 and over 3. So 3 over 3 for that one is 1 for the slope, okay? So for the other pink line, that's up 3 and over 3. So that's 3 over 3. So that's 1 as well. So the pink lines are parallel because they have the same slope. All right, the green lines, let's see if they're parallel. Okay, so that's down 3 and over 4 this time, okay? So down 3 and over 4, negative 3/4. Okay, this one is down 3 and over 4, negative 3/4. Okay, so it is a parallelogram, right? Because these two are parallel, right? That's parallel. And these two are parallel, right? Because they have the same slope. Okay, but is that a 90? Are these negative reciprocals? 1 over 1, you flip it over, it's not negative 3/4, so that's not a 90 this time, okay? So it's not a rectangle, it's not a rhombus. Are all the sides the same length? Let's see if all the sides are the same length. I mean, it's obvious that it's not, okay? This one was a 3/3, right? This one was, and we don't worry about slope anymore, 3/4, so that's different. So this one's going to be different. This is actually a 3/4/5. Remember we talked about 3/4/5s? Okay, this one's a 3, 4, and a 5. Okay, so this length right here is square root of 3 squared plus 3 squared. Okay, and then this length right here is square root of 3 squared plus 4 squared, which is 5. These are not the same length. So all the sides are not the same length. So it's not a rhombus or a square, and it couldn't be a square or a rectangle because it doesn't have a 90. So it's just a parallelogram, which is okay. Okay. Opposite sets of sides, pink and pink and green, are parallel, so it's a parallelogram. Okay. All right, down here, we're almost done. AM is 8 for this little part side, part of a diagonal. Okay, BC is 10. ADB, this corner right here, ADB right there, it's not the whole corner, it's just a part of a corner, right, is 52. Okay, what's AC? Well, AC is the whole diagonal. If the part of it's 8, you know these are the same because diagonals bisect each other, right? So 8 and 8 is 16. Okay, AD is opposite to this one, so it's got to be 10, right? And then angle BDC. BDC is this angle, right? Don't tell me it's 52. Obviously, this is small, this is big, right? Okay? These are the same in squares and rhombuses, or whatever, rhombi, but it's not in a rectangle. How much is a corner? Isn't it 90? 90, 90. So if that's 90, then this would be 90 minus 52, which is 38. So that's how you find it. Okay, so that's 38 degrees. Okay, almost done. Okay, so BD, hate it when I have to do this. Okay, so that's, what is that, 22? 22 right there. AB is 10. Okay, so BC, what's BC? Well, it's a square. All the sides are congruent, right? So isn't that 10? Okay, BM. If the whole thing's 22, right, then half of it would be 11. So that's 11. Okay, what's angle DAC? Is he going to be a quarterback here with the Cowboys? I don't know, man. I'm worried. I want him. I don't think he should go. Okay, so that's DAC, right? Heading here. That's the one they want. So how much is it? Anybody know? The corners are 90, right, in a square. So if it's 90 and you divide by 2, guess what? It's 45. And as a matter of fact, all of them, 45, 45, 45, 45, 45, 45, 45, 45, okay? So all of those are 45. And then AMB, isn't that just this one? Well, that's a 90, right? Because these diagonals are perpendicular, right? So all of these angles are 90, so that's 90. So that's 90, 90, 90, and 90, okay? So, very good, we're done. Yay, long lesson, sorry, but